Hello and welcome to my channel. This specific video or crash course is going to help you learn the basics of NXCAM, and it will enable you to generate your first toolpath and to create the NC code from the toolpath. Before we get into the video, I wanted to specially mention that I am going to upload many such videos that will help you learn each and everything about all of the strategies that NXCAM offers and all the nitty-gritties inside those strategies. So if you are interested in all of this, please subscribe to the channel right now, and let's get into the video now. So first of all, let us understand what is NXCAM. So NXCAM is a manufacturing application, basically a CAM software, which is also known as computer aided manufacturing. So NXCAM helps you to create or generate your toolpath for CNC machine. So the toolpaths are not directly used by the CNC machine, but rather you have to convert these toolpath into a language that your CNC machine can understand. So this language is called G-code. So in this first video, we are going to take a simple example, but then we are going to touch upon all the elements, starting from importing a geometry to setting up your coordinate system, defining the workpiece, setting up vice, tools, creating toolpath, and post-processing. So all of this will help you to get started with NXCAM and to create your first toolpath. So let's start. So first of all, I have NXCAM application open right now. So inside the application window, you will see some ribbons which will be quite common across various environments, for example in manufacturing. So first you have a file menu where you can create a new file, open an existing file, open even solid edge files, and access preferences and much more. We will go through all of these options later in more detail. Then you have Home tab and Tools tab. These tabs hold various functions on their own, and these functionalities may vary depending on the environment you are in. So right now we are in the gateway, which is the main entry point of NX. So here you will see new, open, similar functionalities that we saw in file menu and many others. So we will cover the functionalities like assemble, load options, customer defaults, etc. as we move forward in future videos. Then on the left hand side, you will see a settings button that will allow you to control the behavior of your resource bar on the left hand side. And then you have other options such as notification center, browser, history or recent files, roles, which is very important, and we will come to that in few minutes. And then you have manufacturing samples, which are related to the CAM environment. So here you can open any existing manufacturing sample that is supplied inside NXCAM by default out of the box. So you can open these samples and observe how they are set up. But today we are not going to go through these samples, but we are going to create our own project. So let's start by creating a new file inside NX. So once we select the new button, NX presents us with a new dialog where we can choose the type of file that we are trying to create. So here we can choose to do a new model, a drawing, an additive manufacturing model, or anything else. Currently we are interested in a manufacturing file. So we will choose manufacturing, and then inside templates we will choose blank. We can also refer to an existing file in case we already have a 3D model and we want to create a new project based on an existing model. We can also change the units if we want, but right now I will go with the default, which is millimeters. Then we can define the file name and the place where this file is going to get saved. Again, this is fine for now, so we will click OK, and then we will jump into the manufacturing environment. Once we click OK, NX presents us with the manufacturing environment, and this is where all of the programming will happen. Don't get overwhelmed by all of these buttons and options that you see right now. We are going to go through many of them right now in this video, and by the end you will be familiar with a lot of them, and you will find this at home, and it will be the best place you will want to be inside your system. So we see this little dialog first of all, because currently all the buttons are grayed out. So we have to get rid of this dialog. So what does it say? It basically asks us for the session configuration and the setup that we want to create. So it's not like we need to specify anything right now. We just keep it to default, which is Scam General and Mill Planner. We can configure everything at a later point once we start building our setup. And we want to be flexible, so we will go with the defaults. But if you want to choose any specific setup, for example, turning, or you want to build on a session that has some configuration on library, on prismatic part, etc., then you can choose your configuration or your setup accordingly. Let's click OK for now. And now we are in the manufacturing environment. So inside manufacturing environment, notice that you have a lot of other ribbons, such as besides home, you have geometry for functionalities on everything geometry related. Then you have analysis tab for analyzing your model, view tab to control everything around view, creating section, planes, etc. Display tab to control the model display, selection tab to handle how the selection happens inside NX, assemblies to import new models, define relationships, moving the components, etc. Tools tab to help you with any miscellaneous functions such as moving objects, assigning materials, expressions, recording, etc. And then the application in ribbon that holds all the rest of the environments, and you can from this ribbon access any other environment such as modeling, drafting, and many more. And then we have machine. Again, you can choose to have various other tabs also. You can customize this basically by choosing the right mouse button and enabling or disabling any other environment or the ribbon. But right now, let's go back to the default, which is go back to the home, which holds all of the important functionalities. So inside home, we have many important buttons that are going to help us to create our toolpath and to do everything else. So it's like a workflow. So if you start from the left, you first want to create your tools. Then you have to set up your geometry, and finally you create your operation. Then you have options to choose any strategy that NX tells you would be the best fit. So it predicts your behavior inside NXCam, how you use the application, and it tells you what would be the most probable strategy that you may want to use. And then you have additional actions such as generating your toolpath, checking your toolpath for any collisions or gouge, validation report, verification of the toolpath, simulation, post-processing, and then many other functions that we will take a look at in the later part of the videos. On the left hand side, you have assembly navigator, where if you have an assembly, you will see a whole structure. Then you have a part navigator, where you will see everything related to your part, such as the model tree, your planes, sketches, features, etc. And then the most important thing is operation navigator, where we will be spending most of our time inside NXCam. So these two things are most important. First is the home tab and second is the operation navigator. This is where we have to be in case we are working in the CAM environment. Now remember, in the beginning I told you that roles are very important. You have to go to roles, choose industry specific and set it to CAM advanced. So you can double click on it and choose OK, and it will set your CAM environment to a more advanced user interface or layout, where you will have most of the common functionalities available. You can still configure the roles depending on your preference and how you use NXCam day in and day out. But let's go with the default role. Now we are back to Operation Navigator and the Home tab. So we have to start with the model now, because we need something to generate our toolpath on. So currently it's empty. So let us import an example part file that I have available with me. So I will go to File, Import, and then I will choose Step File. So step 214, I will browse to the file in the Explorer. So now my 3D model is finally imported from the step file. Similarly, I would want to import a vise. Obviously, this part will not be machined on its own. There will be some work holding device that will be clamping this part on the machine. So we will be using a vise right now. I have this vise already available. So I will import this vise as well. So finally, the vise is also imported. Let's double click in the empty space to fit everything on the screen. Now notice that the part is out of the vise actually. It's not completely fitting the vise. This will be the case most of the times when you import multiple objects in NXCAM, because obviously all of these parts will not be fitting well with each other immediately the first minute you import them. So you have to align them properly so that they are located in the right place. So how do we do that? We can either move the vise or the part. In this case, I think moving the part will be an easier choice. So let's do that. I'll go to the Tools tab and choose Move Object command. So the Move Object command helps us to move the part file or any other geometry inside the environment, inside CAM environment specifically in this case. So I will choose the part and then I will choose the method by which I want to move this model. I will choose point to point method. I will choose made point here on my workpiece, and then I will choose the midpoint on the fixed jaw. Once I do that, I will hit apply. By clicking on the apply button, the dialog box stays open and my first operation, or rather the function, executes. So in this case, the part is now moved to that midpoint. Secondly, I want to move this part slightly on the inside of these two jaws. So I will again select this object, but this time I will do a dynamic move. I'll choose the Z axis and move this part, let's say -8 millimeters, so that it goes on the inside. I'll click OK. And now you can see that the part is on the inside of the fixed jaw. So you can notice that the part is now inside. But on the other hand, we have some problem here. The part is actually on inside the jaw. We don't want this. So the thing is, we have to move this jaw also. So how do we move this jaw? First, we have to know what is going to be the exact distance. So either we can use the same method, that is moving this point to the midpoint of the part, or rather we can analyze the dimensions of the part, which is going to be a very handy function for you whenever you are working on any part. So if you are working on a 3D geometry and you are going to machine that part, you have to know the dimensions or the size. So you can use this measure command to actually measure the dimensions such as height, length, width, angles, distances, etc. all sorts of things. So I've chosen the object type measurement and I selected two faces on the model. Notice how NX automatically presents the distance, which is the minimum distance right now based on my selection. I can also choose points or bodies in case I want body or point type measurement. I can also have point selection, vector selection, and much more. So if you want to understand more about this measure command, let me know in the comments. I will create a detailed video on the measure command also. So now I know that the distance is 100 mm. I'll click OK. So now let's align the second jaw with this part. So to align the second jaw, we will use the same command, but we will use a shortcut key now, that is Ctrl+T. Then I will choose the object, and now I will select distance between points method to actually define the distance between the jaws. So I'll select the origin point and then I will select the measurement point and the vector. So I can choose these vector directions to define the direction along which the movement has to happen. Now once the direction is defined, I can define the distance, in this case 100 millimeters. So this will actually move the part. But notice that we were not interested in moving the part, so I will shift and then deselect, shift and click on the part to deselect the part, and then instead select the second jaw. Notice how I went back to my selection and changed it by using the shift key. So you have to press and hold the shift key, and then if you make any selection, it will deselect that object. Then I will click on the OK button, and then my second jaw is also moved. And there we have it. Our setup is almost ready. So the next thing that we need in our setup is the blank geometry or the stock. So the stock is required to define the initial material. So obviously when we are going to manufacture this part, there will be a raw material. So we are now going to define the raw material for producing this part. So we can go to the geometry tab, and then inside the point drop down, you will see bounding body command. So this is very useful, and it can allow you to define a block, for example, or a cylinder. So I can choose the object, and NX will automatically generate a bounding body, in this case a bounding block. I will define a 0 mm offset because I don't want any additional offset, but rather I'll just add 1 or 2 millimeters of distance here. So basically a top offset, because I want to do a face milling as well. So I'll explain what that is in few minutes. I'll click OK. And now our stock model is also defined. Now with everything defined for our setup, we just need to get rid of these coordinate system, or at least do something about them. So the coordinate systems are these. You can see these coordinate system XM, YM, ZM and XC, YC, ZC. And then you also see this coordinate system in the bottom left corner of the graphics area. So this is the universal coordinate system or absolute coordinate system, whatever you want to call them. This basically indicates your main coordinate system, mainly the directions. It is not the place where your main coordinate system is located because it is static and remains fixed on the screen. The second thing is your work coordinate system. So if you press W, your work coordinate system will get hidden. If you press W again, it will be shown again. So depending on the use case, you can enable this, but right now we can simply hide the work coordinate system because we don't need it right now. So the last thing, but the most important one for CAM programming in NXCAM, is the machine coordinate system. So machine coordinate system can be defined by going to your operation navigator, and within operation navigator you have 4 views: program order view, machine tool view, geometry view and machining method view. So the machine coordinate system can be defined by going to the geometry view. We are already in the geometry view, and choosing the MCS. So if we expand the MCS, you will see workpiece and another MCS. So these objects are coming by default when we started the manufacturing environment. Remember that initially we chose a CAM General and Mill Planner setup. That is where these objects are coming from. We can delete them and redefine them if required. So for example, I can delete the local MCS because I don't need it, and I can rename the MCS main and just call it MCS. So it makes no difference, it's just a name that I can define for any of these objects. The important part here is the location of the MCS. So MCS will basically give a reference for your toolpath, and whenever you post-process your toolpath, it will generate the output coordinates XYZ values in case of 3 axis with respect to this machine coordinate system. So your machine will also have to be set up accordingly, and that is how your machine will know where it has to go. So for each point there will be X, Y and Z value. That X, Y and Z value is defined with respect to a certain point, and that is what this MCS is all about. So for us, I would want to simply keep it on top of the blank or the stock. So I will choose the stop face, and I have chosen CSys of object, that is coordinate system of object. Automatically this coordinate system is now aligned with the center. I will also link this reference coordinate system with my main coordinate system. Reference coordinate system is not of much use in the beginning right now, so we can just set it with respect to MCS right now. If you want to learn more about reference coordinate system, I'll cover it in the later videos and the use cases. Next is the purpose of this main MCS. It is also important, so we will change the purpose of this MCS to local, and we will set it to fixture offset and give the fixture offset value as 1. So the value of 1 will basically mean that the fixture offset will be output as G54. So G54 is important because on the machine we will be setting this offset value, and machine has to know which offset to use. So if we set 1, the value of G54 will be output in our NC code. And that is why we have to choose local, because we are using a local coordinate system right now. It's not a main machine coordinate system as such, and that is why we have to choose local. We can define a clearance plane also at this point, but let's keep it automatic. You can always change it. We will cover the clearance planes also later. Let's hit OK, and our MCS is also defined. Let's define the workpiece now. So we are getting close there to our toolpath. We need to set up the workpiece though. So for workpiece, we need to set up 3 main objects primarily. The third one can be optional depending on whether you have it available or not. But the first 2 are mandatory for most of the toolpaths. So first one is the part. Obviously, you need to define the finish part. So I can keep my cursor on the object, on the workpiece or blank, and then it will give me choices. I will choose the final part, which is my workpiece, and then I will choose blank. So for blank, I will define the blank geometry that we created earlier, and I'll click OK. And last is check. Because we already have the fixture defined, we will define this as our check geometry. So this check will be used to avoid completely when generating a toolpath. So if we have this kind of setup, NXCam will try to avoid the jaws and ultimately prevent any kind of collisions that may happen when you actually run this toolpath on your machine. You can define additional offsets right now, but we don't need to right in this case. So we'll click OK. And then if you select workpiece, you will notice that everything is completely defined. These colors indicate that something is defined as check, something is defined as blank, and your workpiece. Now with this setup, let's go ahead and define our tools, because remember we started with the process. We had to define our tool, the geometry, and the operation. We defined geometry already because it was the first thing that was coming on our operation navigator. Obviously there is no specific order as such. You can start with geometry, then define tools, or even you can create operation and then inside your operation define geometry and tools. So it's up to your preference, but then it is also recommended that you start from the left. Now let's go ahead with the tools. So to create tool, you can select the create tool button. Now you have a lot of options. You can choose which type of tool you want to create, whether it is a flat end mill, chamfer mill, ball mill, spherical mill, etc. I can also retrieve tools from the library. So if I choose retrieve tool from library and I choose a milling tool, then I can give a, for example, diameter of 20, and I can call a 20 millimeter tool. I'll click OK. I'll call another tool, this time let's say a 50 millimeter for facing. And we can see the preview of these tools also if you want. So we can see the preview as well. I'm happy with this tool. I'll click OK. In case I want to create any other tool, I can select the tool type, click OK. And then I can define the diameter and various other parameters that you see on the screen. So depending on these parameters, the visual will also update. You can see the tool getting updated, and then you can also define various other parameters. For example, I'll define the flute length, total length, even define the holder. For example, I can go to the holder library, retrieve a new holder, or even I can choose to create a holder on my own. But right now I'm happy with the predefined holder from the library. I can define the insertion offset also if I want to. I can define it as 5 mm, let's say, and I can give the tool number also. So I already created 2 tools, so I will give this tool number 3, and I will also give adjust register and cut comp register. These are basically length adjust offsets and cutter compensation offsets. More on these in the later videos. Let's click OK, and my tool is set up. So if I go to the second view, which is machine tool view, you will see all these tools defined over here. I can also configure these columns so that I see the relevant information immediately. So you can easily configure these columns if you want. You can go to column configuration and then configure your columns. We'll cover this later, but then it is possible. Let's check if these tools have the right tool numbers. They don't, so I will define the tool numbers. Now all the tools are defined with the tool numbers. So now we are good to go to create our first tool path. Now let's hide the blank for simplicity purpose. So we will go to the part navigator and hide the bounding body. Notice that the other bodies are imported. These are coming from our step file, so we can ignore them. In case we want to make any changes, we can do that by going to the geometry tab and using the synchronous modeling functions to alter or change any type of geometry. But let's start with the toolpath. So I'll go back to geometry view and go to the workpiece and then right click and go to insert operation. Alternatively, I can select this object and click on create operation. You can also go to program order view, for example, and choose the exact location where you want to have your operation. This view, program order view, helps you to organize your programs and the sequence of those programs. So it is also very useful in case you have, let's say, multi-channel machines and you have, let's say, group of milling toolpaths and turning toolpaths. You want to organize them logically and in a sequential manner. And there is a last tab which we did not talk about so far, that is machining method view. So the machining method view will help you set up some predefined settings, such as if I go to mill rough, you can see the stock or in tool out tool. So you can define a existing value that will be applicable for all the operations sitting inside this group. So if you set a stock of 0.5 mm, so all the operations under mill rough will be using this 0.5 part stock value. And similarly, you can choose the in tool and out tool. These are basically tolerances. These allow your toolpath points to go inside the part or outside the part. So if it is balanced, then it mostly means that your toolpath point each toolpath point will basically vary between a certain tolerance range. So obviously the toolpaths are calculated on mesh in many cases, and there is a tolerance that comes into play. So this tolerance helps you to control to a larger extent the accuracy of your toolpath. Obviously you would not want to make it 1 micron, otherwise your toolpath will take so much time to generate. So let's go back and let's go to the geometry view now and start creating a new toolpath. So I will click on create operation now, and from create operation dialog, I will choose program because I want my operation to be created inside the program group. I will choose the 20 mm end mill, and maybe I want to start with the face milling, so I'll choose the inserted 50 mm cutter. I'll choose workpiece geometry, and then for method I will just keep method, doesn't matter. Then I will choose floor facing without wall as a strategy. I have a lot of other strategies, as you can see, and I don't think it will be doable for us to go through all of these strategies in a single video. But like I said earlier, we will be going through all of these strategies in series of videos over time. In case you want me to cover any specific strategy early on, please let me know in the comments. If you have any questions or queries in general on any of these operation types, again, please drop your question in the comments. I'll be more than happy to help you there. And one important thing, it's not just these strategies. By the way, you have mill contour, mill rotary, so many other things. So if I go to mill contour, which is basically for 3-axis machining, You have various things like cavity milling, adaptive roughing, etc. Let's stick to the basics right now. We'll go to Mill Planner, and we were trying to create floor facing without wall because I want to do facing on top of this part and I do not have any walls right now. So I'll click OK. Now for this operation, there are certain types of minimum inputs that are required, which is the floor or the cutting area. So I will choose this floor, but don't worry actually, because my toolpath is not going to be restricted to this floor. I have various options to control the extents of my toolpath. But let's go through some of the options, actually not all, because there are too many. And again, as I said earlier, and as I've been saying, due to limited time in this video, we will not be able to go through all these options, but then in future, we will eventually cover all of these options in more detail. So for now, because our toolpath needs some very essential settings to successfully create a good toolpath, I will choose zigzag. Maybe I will choose a step over value of maybe 70, which is fine. And my tool is defined, so it's all good. If I go to feeds and speeds, I can set a speed, surface speed, feet per tooth, spindle speed, for example. Let's keep some arbitrary values, and we can calculate the surface speed and feet per tooth accordingly. We can also control the rapid modes and then additional feeds such as approach feed, engage feed, etc. Let's go to cut region, which is also where our overhang value is defined. So I'll set it to 10%, for example. If you're not sure what each of these options do, then you can also keep your cursor on some of these labels, and a graphical pop-up will be shown, which can help you better understand the purpose of this function or this option. So for region, I want to extend my toolpath to the blank outline, which is the outer boundary of my blank. Then for strategy, I think everything is good. For connections, I think it's also fine. Let's go to non-cutting moves, which is basically everything else besides cutting. That is non-cutting. We'll go to engage. Maybe we will choose a linear type engage and maybe relative to cut. So wherever the tool is entering, in whichever direction the tool enters, my entry will also be relative to that direction. And for the length of my engage move, I will choose a safe distance, let's say 70%, to give sufficient clearance to my tool. So with that done, let's see how our toolpath looks like. So I would always recommend you to click OK and then generate your toolpath. So all of your settings and whatever you did so far for the operation would get saved, and then your toolpath would get generated. So notice that our first toolpath is ready, and we can already see this in the graphics area. So it looks beautiful, right? It's not just sitting there idle. We can do so many things from this toolpath. For example, you want to see how the material is going to get removed, right? So we can show the IPW, which is in process workpiece. So our initial blank is now active. Let us slow down the simulation a little bit, and then I will play the animation. So the toolpath will now be simulated. So notice how the material gets removed. The tool is moving along the toolpath, and this is how the machining will also happen once the toolpath gets on the CNC machine. But now I think we are good with this toolpath. It's all fine. We don't need to make any more changes. Let's go to the next step, which is machining this next step. So for this, I think an appropriate way would be adaptive roughing. So maybe I will go to mill contour. Although this is not a contour, I think the easiest way of generating an adaptive roughing toolpath on a stock model is using a 3D adaptive roughing. Let's choose a 20 dia end mill. It has some corner radius, so I think it will leave some material in the corner, but I think it should be fine for the example. Let's go ahead with the 20 mm end mill and a 3D adaptive roughing toolpath. Let's set the step over to 8% of the tool, which is good enough for us. Maybe for cut levels it is important now because we have multiple levels here. There's a top level, there's mid level that we see here, then we have a bore also or a counter bore, and then we have bottom level as well. So I want to specify the top level and the bottom level to be this. I only want to machine this region and not anything else. I think this should be fine. And for the geometry, I want to consider the 3D IPW, which is basically the in-process workpiece. So if I'm considering the 3D IPW, it will also take into account the stock with the previous operation. So remember the material that was removed after running face mill operation. That is what will be considered for this 3D adaptive roughing now. So let's click OK and let's see how our toolpath looks like. So I will click on generate. So the toolpath already looks fantastic. It is going around the block. So in this case now, let's see if we can avoid these moves. I can already see that there is some additional material here on the stock or the blank geometry. So maybe we will go back to the bounding body, to the initial step where we defined this body, and then let us analyze if there is any offset now. So there's some offset. Let's make it 0 mm first. All right. And then we will disable the uniform offset. Let's click OK. And then the offset is gone. Maybe I will just want to add offset, but only on the top face, which is what I initially wanted, but I think the uniform offset option was on, due to which the offset got applied everywhere. So now all I need is to regenerate the toolpath. Again, I don't think there will be too many changes on the first toolpath. It looks good already. Let's see the second toolpath now. Hopefully it doesn't go outside that region, and yes. Now we have a very nice toolpath. Let's hide the bounding body very quickly. So our toolpath is already looking good. Let's see how it works in action. So I will run the simulation now. Maybe I'll hide the toolpath and maybe make the simulation a bit faster. So you can see with this adaptive roughing strategy, the tool gradually engages the material and the material removal rate always stays constant. So this greatly increases your tool life and also greatly reduces your machining time because you are fully utilizing your cutting edge of the tool and then removing the material at a much faster rate. So our floor facing is done. You can notice that our toolpath looks good. Both of the toolpaths are looking really nice. So now let's machine this pocket with the planar milling strategy. Let's go with some strategy that allows me to define closed pocket with floors and walls. For example, in this case, I can choose this pocket milling strategy. I have defined the tool already. Let's select OK. Now I need to define the walls here. So these are my walls. So everything looks good. Let's see how the toolpath looks like. So the toolpath has generated, but the step over is quite big. Let's reduce the step over. Okay. The toolpath looks fine right now, but the thing is it has taken a single cut, a helical entry, and then it is removing the material, which would practically be impossible. So what we need to define is the depths of cut here. So maybe we can apply a realistic depth of cut, but in this case, I'll just choose a depth of cut of 2 mm. So notice how the tool is going to gradually enter the material with helical ramp, one pass at a time, and it is going to remove the material in this fashion. So if we see the simulation for this toolpath, Notice how it removes the material one by one. Looks good, right? So everything is clear. Quite a large amount of material from our part is already gone. There are only some regions left, but I think we can cover those later, such as these bits. You can still clear these portions using other strategies such as profile or any kind of 3D profile strategies. There are various ways of doing it. Now let's quickly create some drilling operation to drill these holes. So for drilling, we can go to create operation and choose hole making. So within hole making, we have spot drilling, which is to create an initial pack and then do a drilling. Let's go with the drilling operation right away. I'll click OK. Now in this case, I'm in the drilling operation, but I do not know the diameter of the holes, which is actually wrong. So I'll go to analysis, measure, and within operation dialog, I'm doing the measurement. If I select this cylindrical face, I will see the pop-up, which is radius 3.5 millimeter or the diameter 7 millimeters. So I can directly create a tool with a diameter of 7 millimeter. So I will choose a standard drill. Let's keep it simple. I will give the diameter 7 millimeter. No need to define any holders for now. Let's give the tool number. And the last thing that we need to define is the feature geometry. So depending on the operation that I have chosen, the features will be recognized automatically along with their parameters. So I'm going to create through holes. So I'll click OK. I can define feeds and speed also and control various other settings, but let's look at them at a later point in time. I'll click on generate and this is my drilling operation. We can also verify this, let's say with or without material removal. I'll just slow it down a little bit. Maybe it was too fast. This is how it looks like. Looks quite good now, and I think most of the toolpaths that we wanted to generate initially are good. So with this done, let us simulate one of these toolpaths on a machine. Sounds exciting, right? But let's do that. So we'll go to machine tool view, double click on generic machine, retrieve a machine from the library, let's say a milling machine. I'll retrieve a 3-axis milling machine with Fanuc controller. I'll select OK. And then I want to position my machine with respect to my part. So I have to measure this height and accordingly move my part. So how do I do that? I can actually find the total distance from the top face all the way to the bottom of my vise. So my vise face is located somewhere over here. So in this case, this is my vise face. So the distance approximately is 91.6838. I'll just copy this value. I'll go back and now I will simply choose the part mounting junction and then I can move the machine downwards. So I'll give this value, press enter, and there you go. My machine is perfectly located with respect to my setup. Alternatively, I can also adjust my setup as per the machine. Both the ways should be fine. And now with this machine in place, I have some coordinate system. So I can hide this coordinate system by using a show and hide command. So I can press Ctrl plus W key to activate the show and hide command. And here I can hide all the datums. So my coordinate system is hidden now. And now let's go to the simulation tab. So before I go to the simulation tab, I just want to make sure all of my tools are properly located. So one of my tools seems to be outside the pocket, so I will move it inside the pocket. Just we have to make sure that each tool is located in a pocket and we only have one tool in one pocket. Obviously we cannot have multiple tools in single pocket, and you can see these tools are located here in a nice place. And you can see also the tool without the holder, which we intentionally defined because I just wanted to show you how it actually looks like without the holder. You can have this kind of arrangement, but then it is not very realistic. In case you are not simulating with the machine, then you can safely ignore it. With simulation, it is not very good. So let's simulate our floor facing toolpath. I'll go to simulate machine. You have two ways of simulating your machine. Let's organize the views first. So I will move these windows. Looks good. I'll just give some space to the machine. And now we can simulate using different ways. We can use a toolpath based simulation, machine code based simulation, or external program simulation. In this case, let's say we will try machine code based simulation, and what NXCam will do is use the post processor available with this machine to generate the G code, and then when we simulate, it will actually run this G code and move machine accordingly. So I will also display the tool trace. I'll hit the play button, and with the same settings with tool trace on, NXCam should start simulating the toolpath. Maybe I can speed it up a little bit. And if I zoom out slightly, notice how the slide moves, indicating the real behavior of the machine as per the coordinate systems that are currently generated. So our toolpath looks quite good. There is no collision as such. I'll click finish. And the last step in this case would be to post process. And if you want to hide your machine, you can just go to assembly navigator and hide the machine. You can even hide the fixture objects through this way if you want, but yeah, I think it should be fine with the fixture. So let's keep it on. Now let's go back to operation navigator and do the final step, which is post processing. So let's take this, maybe the adaptive roughing toolpath, and we'll click on post process. I'll select 3-axis mill vertical. I'll click OK. With the default post processor, so because it was a Fanuc controller, so you will see this header and then all the supporting code, and then you have your coordinates, and it's a long NC file, but this is how you finally get your NC code, and this file would also be saved in the specified directory which we chose at the time of post processing. So with this done, I hope you found the video useful. I hope everything that we covered in today's video was helpful and you were able to understand the whole process in NXCam, starting from importing your first part to post processing. And we created quite a lot of toolpaths such as facing, adaptive roughing, pocketing, and even drilling. So we will go into more details in the subsequent videos, but please let me know in the comments if this was helpful. And if you have any specific questions in this video pertaining to the functions and the strategies that we covered, you can drop your questions in the comment. Don't forget to subscribe because I'm going to upload more such videos, as I said, and please put your request also in the comments and I can plan the subsequent videos accordingly. Thank you very much for your time, and I'll see you in the next video.